Okay, so problem 8.4. In trapezoid EFGH, we have that EF is parallel to GH. EF is 6, so let's note that. EF is 6. FG, the length here, is 10. GH is 12. And EH is 8. Find the length of the median NM. MN. Alright. We have a lot of lengths, and we know that N is the midpoint of the H, so it splits up into 4 and 4. And likewise, over here would be 5 and 5, because M is the midpoint of FG. But it's still not telling us really much about MN. We have like everything we need except for that side. Well, if there was a way to show that if MN was parallel to EF or HG, we could create a proportion with that. But I don't have any obvious way to do that right now. The only thing I really know is that HG and EF are parallel. Well, parallel makes me think of congruent angles. But the only way I could get congruent angles in this diagram is if I were to extend the lines EH and FG so that they made a triangle. So let's actually do that. Let's draw this diagram again. However, instead, we are going to connect them at a point so that they form a triangle. So, for example, this line right here will be my new EF. This one will be NM. And we'll get the triangle H, G, M, F. I'm going to call this X. Then we have E, N, and I'll fill in some of the lengths we have. We know that these two sides are parallel, which means corresponding angles are the same. And that implies we have similar triangles. So, what we have just discovered is that triangle XEF is similar to triangle XHG by angle. Okay. Well, that's pretty important, especially because now we can form some ratios. So, for example, we have that XE over E8 or XH is equal to XF over XG, which is equal to EF over XG, or no, HG. Alright, well, why is that so important? Well, I want to show that NM is parallel to EF or HG. That way, if they are, then I can make a ratio with them. And if I can make a ratio with MN, then it'll be easy to find the length. Now, if I could figure out what XE and XF are, then maybe I could show that triangle XEF and XNM are proportionate. But I need to find out what those lengths are. because I have no way of showing if any of the angles at the median are the same or not. So let's try to find one of those measures. Now, XE is what we're trying to find. But XH, do I know anything about that? Well, XH is the same thing as XE plus that additional side EH, which is 8. And similarly, XF and XG. Well, XG is the length of XF plus the additional length of 10. And FEF is 6, HG is 12, and that would simplify to 1/2. So from here, it should be relatively easy to find the missing sides. So let's take XF for instance. XF over XF plus 10 is equal to 1/2. And if I cross multiply, I'm left with 2XF equals XF plus 10. And if I subtract XF on both sides, that means I'm left with that XF is equal to 10. Okay? So, XF is 10. And through a similar process, I hope we understand how I can solve for XE and find out that that is 8. Now, why is that so useful? Let's clear off some of this work. Well, now that we have established what those lengths are, maybe I could show that XEF and XNM are similar. Well, they both share an angle at X. And let's see if the sides are proportionate. And in that case, we would have side angle side. So, XE is 8. And XN is 12. Then we have XF is 10. And XM is 15. Now, if these ratios are the same, then we have a proportion. Well, 8 over 12 is the same thing as 2 over 3. 10 over 15 is also 2 over 3. So yes, we do have that they are proportionate. So then that means that triangle XEF is similar to triangle XNM by side angle side. Now that tells us that the corresponding angles are congruent, which means that the sides are all parallel with each other. So NM is parallel to EF and HG, which means that I can now solve for NM. Because making a proportion, we have that NM over EF, which is 6, is equal to the 3 over 2 by doing 12 over 8. Multiply by 6 on both sides, and we get that NM is equal to, well, that would just be 6, half of 6 is 3, times 3 is 9. And we get our answer. Now, one of the important theorems we have with trapezoids is that the median of a trapezoid is parallel to the bases and equal in length to the average of the lengths of the bases. So, what does that mean? Well, if I look at this trapezoid in the original diagram, and let's look at the lengths of the bases, 6 and 12. Well, what's the average of that? Well, 6 plus 12 is equal to 18. And to find the average, you would have to divide by 2, and you would get 9, which leads us to our answer. So, one of the theorems that we now know about is that if I want to find a median, take the average of the bases of the trapezoid. And this will become very important in the next couple problems.